there's a WhatsApp for anybody that still not on the WhatsApp group, and you're watching this, please, you can join our WhatsApp group. Just send me a WhatsApp on 083-790-8387, or there is a link in the chat as well. Okay, so today we're going to just do a recap of study unit 10. Next week, Thursday, we'll do study unit 11, and then over the weekend next week, we'll do a recap of study unit 11. Okay, so study unit 10, we're looking at chi-square analysis. So basically, what we're doing with chi-square is we are looking at trying to establish if two variables are independent from one another. So we did some of those types of work in study unit 4 when we looked at probability, and via probability we wanted to establish if two variables are independent or mutually exclusive or something like that. Now in study unit 10, we use another statistical method, and that is the chi-square, to actually decide if two variables are independent from one another. The nice thing with chi-square is there's nearly a process that you can follow, and again, we will nearly see in all the questions that we're going through today. I've just took some more out of a book, so there will be nearly a few steps that we will follow. So the first thing is that we will look at is we're going to identify the null and alternative hypothesis. And here it's always standard. It's not like in study unit 9 where it could have been bigger or smaller, not equal to all those kind of things. In chi-square, we basically have the null hypothesis will always be the test for independence, and your alternative will be the test for dependence. Okay, so that is standard. So if in a question they tell us H0 is dependent, then we know that statement is wrong. Okay, so this one is for chi-square, it's always the same. The null hypothesis will be the one testing for independence, and your alternative will be the one testing for dependence. Okay, so that is very important. Then the second step is to basically work out what your degrees of freedom is. And again, here's a bit of a difference between this and study unit 9. Study unit 9, when we did the T distribution, with the T distribution, your degrees of freedom was and is always n minus 1. But here with a chi-square, our degrees of freedom that we work out is a bit differently. So the degrees of freedom is, because we sit with a table, it's going to be row minus 1, and you will multiply that by columns minus 1. Okay, so let me quickly, I think here's a table. So if you look at this, gender, there's 2, So there's 2 rows, so it will be 2 minus 1. When we look across how many sports, there's 1, 2, 3, 4. So 4 minus 1. So if we needed to do the degrees of freedom in this one, it would have been 2 minus 1, which is 1, times 4 minus 1, which is 3. So the degrees of freedom is 3. Okay. And it would have been correct in this question that we will go through a bit later. But that is how we will work out the degrees of freedom. So it is a bit different from the degrees of freedom that we do in the t-test. So just important, because they might throw in a question that says define the degrees of freedom of a t-test, and they give you options that include the chi-square, or they can do it the other way around. So just be careful that in this 11 chapters that we're doing, there are 2 degrees of freedoms that we work out. So for the t-test, it is n minus 1, and for the chi-square, it is row minus 1 times columns minus 1. Okay, so just please remember that. So that's the second step. Then the third step will be that somewhere they will need to tell us what the alpha is, and normally, like in the other test that we did, we normally work with a 5%, so they can also maybe say 95, 10, and 1%. So that's for alpha. When we look at the t-table, and that is also just something that is, or sorry, the chi-square table, the one difference between chi-square and the t-table. So remember, let me quickly show. Let's make this a bit bigger. So remember, when we work out the t, it's always the degrees of freedom, and then it's the alpha divided by 2. So that's how we get to the t-table. When we go to the chi-square table, important here is we're working with an alpha. So not alpha divided by 2, we're working with alpha. Okay, so that is important because when we work this out, we actually will work with the 1%, the 5%, and the 10%, and not 1% divided by 2, 5% divided by 2, and 10% divided by 2. So we will work with only the alpha value and not divided by 2. So that, again, is one of the areas that's different between t-distribution or a t-table and the chi-square. Okay, and then step 4, like in when we did Z or T distributions, we needed to work out the test statistic. Again, here it's been done a bit differently. So I will show this again to you guys in one of the problems, how we're going to work that out. And then the last step, as always, we will need to make a decision. So we need to make a decision if we reject or accept the null hypothesis. But here's a nice rule nearly that they've created for us. So if a t-stat that we're working out in this instance is bigger than your critical value, we will reject the null hypothesis. And so that is one, again, that you can just, you don't need to study, or that is just, that is a rule. Okay, so again, this is when you prep for your exam, this is something that you can, again, have printed, have it with you. You guys are writing open book, so all your notes are allowed, you are allowed to have it with you. So there's definitely no problem in having this. So definitely, again, I think this one is one that you can just write down somewhere when you start with chi-square, because you then don't need to nearly think or where they want to try to catch you out sometimes. So if t-stat is bigger than critical value, you reject the null hypothesis. Okay, so let's get into a few examples. The other piece that I took out of your study guide, which is a very nice summary nearly, is this block. Because in this block, we actually, it's everything that we need to do. So here's your step 1. There's your step 2. Okay, they will give us your alpha, so that's the step 3. Here is your step 4, and then lastly, you will need to make a choice. Okay, so what I like to do is always, when I start with a example, I just copy it over and have it in my as a reference, because then one can easily check which ones do we need to look for, and it just helps. Okay, so let's work through this first question. Okay, so we get the table. It is about men and women that have favorite sports, and they ask us that we need to check at the 5% level. So there's your alpha, and test to determine whether sport preferences depend on gender. So basically, is there a difference in preference in sport according to the gender of the person? And then they ask us which one is incorrect. Okay, so firstly, gender and favorite sport are independent. Gender and favorite sport are dependent. Okay, so they should have added here H0, so we're missing a bit of information. And they should have added here, because H0 is always the one testing for independence, and H1 is always the one testing for dependence. So they have forgotten in these answers just to add the null and alternative hypothesis. They can have it in front, or they could have had it at the back just to say which ones, but obviously somewhere a typo and they've forgotten to add that. Okay, but null hypothesis always independence. The alternative is dependence. Just another thing for you guys, not independent is exactly the same as dependent. So sometimes they use the not independent word, sometimes they use dependent. Okay, so just another one where sometimes they try to trick me with the English that they're using. So just be on the lookout for all those things that might be similar, um, but it's actually just a twist on words. Okay, we've done the degrees of freedom. So let's work out the critical value. So the critical value, we're going to look at the chi-square table. So let's say that is chi-square, where degrees of freedom is 3. And we know that alpha is 5%. Let's 3 and 5%. Okay, so 3 and 5%. So that is 7.815. 7.815. So the critical value is correct. Okay, so degrees of freedom was right. We worked that out. Then just a recap on the critical value. Degrees of freedom with a 5% level. So we're working with a chi-square. Degrees of freedom is 3. At the 5% level, 7.815. And then the last one, suppose that the t-stat is 3.3. Okay, so let's quickly, what did we say? T-stat bigger than crit, then we reject the null hypothesis. A t-stat bigger than crit, then we reject H0. Let's see, t-stat 3.3. Your crit value is 7.815. Okay, so it's definitely not bigger. So it's smaller. So we do not reject the null hypothesis. Okay, so if your t-stat was bigger, then we would have rejected the null hypothesis. T-stat is smaller, so we do not reject. Let's read what they say. Suppose that the calculated t-stat is 3.3. The conclusion is to reject the null hypothesis. That is the incorrect one, because we do not reject the null hypothesis, because our t-stat is smaller than your critical value. Okay, so I like to always and nearly write the rule down first, and then only look at what they're saying, because I think we'll go through a few of these where, again, they might just, the language that they use might also sometimes be different. So they might have said, so if we do not reject the null hypothesis, it might be that they say something about the alternative hypothesis. So just be very careful, but I think I've got one or two, otherwise I will get us one when we do the prep for the last assignment, just to show all the different words that I sometimes also use in these reject or acceptance and things like that. Okay, so then a bit more of a definition question. So to perform a chi-square test of independence, you don't require. Okay, so again, a bit of a different question, because if you first read you require, then two or more nominal variables is correct, but we're looking for the you don't require. The distribution to be negatively skewed. Okay, that nearly feels to me that you don't need it to be negatively skewed. You do need a degrees of freedom. You do need a level of significance. You are going to test of a contingency table. So the one that is incorrect is option 2. Okay, so your distribution does not need to be negatively skewed. And I think that is important. And specific reason why they did that is because when you look at that graph, it looks negatively skewed. But we can also have that graph the other way around. Okay, where then that just refers to alpha, and that is 1 minus alpha, where you then have a lower tail. Here it is specifically upper tail, then you just have a lower tail. So important that this does not need to be negatively skewed. It can be positively skewed as well. It can be a bit more a normal distribution. What we are looking at is just with chi-square, we're looking to compare two variables with one another. When we use the Z table and T table, we basically look at more comparing two populations with one another. So we're measuring still the same thing. So with both a Z and a T, we might look at the marks of a class and how the marks of a different class differs from that bigger population of marks. With chi-square, what we are looking at is there a difference within the variables? So here we've now asked, is there a difference in the preference on gender for different sports codes? But basically, if we go to some of the next, there's other ways that we are looking at between the two variables. So we could have had the same table with provinces and then say, but there might be differences in favorite sports according to 4 or 5 different provinces that you live in South Africa. Okay, so it's nearly chi-square. We're looking at the data to say, is there differences in the variables within the data? Okay, so another example is here we look at political parties A, B, and C, and we look at different levels of income, and the test is test if there's a significance whether the political reference at the level of income are dependent. Okay, so here we test again null hypothesis, and let's just copy this on over so that you can just again see. So firstly, null hypothesis. What do we do with null hypothesis? We test independence. With an alternative, we test dependence. Okay, so let's see. Null hypothesis, independent, variables of alternative dependent. Okay, so the first one is correct. Then, so that's step one. Step two, let's check for degrees of freedom. Okay, degrees of freedom, rows, 1, 2, 3, 4, the 4 minus 1. Columns, 1, 2, 3, 3 minus 1. So we sit with 4 minus 1 is 3, 3 minus 1 is 2, so degrees of freedom is 6. Okay, degrees of freedom 12 is incorrect. So what they just did is to say 4 times 3, and that was 12. But remember, row minus 1, column minus 1. Then critical value. So let's see, we've got the degrees of freedom is 6. Let's say, what did they say? Use the table shown and test on 1%. Okay, so a bit different. 1% and degrees of freedom 6. Degrees of freedom 6. Okay, that's 10%. There's 1%. Let's check again. 6, 1. 16,812. 16,812. Critical value is correct. Then there are 390 people. Okay, they didn't tell us this, so we need to check. So we will need to add all of those values together to get the 390. So let's quickly do that. It's my calculator. So 23 plus 11 plus 1 plus 40 plus 75 plus 51 plus 16 plus 107 plus 60 plus 2 plus 14 plus 10. Okay, so then I get 390. Okay, so there wasn't any totals here. There was also no totals here. So sometimes we want to get totals, but then we only work it out when they actually ask us for. So if they ask us something on an expected value to work out, then only we will nearly work out the extra totals. Again, your exam is timed, so I would not start off this question by completing all the totals. I will only do it when nearly needed. Um, you guys would have, if this was an exam question, you would have stopped at degrees of freedom, because that one is definitely the incorrect one. So then you wouldn't have needed to know what the totals is. Okay, and then just to check if we reject or not. So let's write down if T stat is bigger than critical value, we reject the null hypothesis. So let's see if they tell us there's the critical value, the 69. Sure, that's big, 0.38. If that is bigger than 16, 812, which it is, H0 is rejected. Okay, and that is correct. So again, I like to write that down when it's simple. When you see, it makes it easier. When you don't need now to to stress about it, because you look for the t-stat value, you look for the critical value, put it in, you see, okay, but 69 is bigger than 16. So because of that, I will reject the null hypothesis. Okay, so again, we nearly covered everything in this table. So for the next one, there it's a bit different. So let's see, I'm gonna squeeze this in. Doesn't want to squeeze. Too many tables. Let's make a plan so that it is there. Okay, so let's look at the questions, and you can actually, I just want to, if don't worry, we'll work in that space. Okay, we get this information. So in this information, what you see is column 1, 2, 3. So this variable, whatever it was, there was 3 of them. 1, 2, 3. And so 3 columns, and there was 2 rows. Okay, so first, let's just check null hypothesis, alternative. Okay, nowhere here do they ask it, so that component we don't cover in this question. Degrees of freedom. Okay, they tell us degrees of freedom is 2. So let's see, here is a degrees of freedom question. Degrees of freedom, row minus 1. That will be 2 minus 1. Column minus 1. So it's 1 times 2, which is equal to 2. Okay, so correct. We're looking for the incorrect one. Okay, then expected values. So let's work out if there is. So they're asking us in question 5, the expected value of row 1 and column 3. Okay, so the formula, row 1, the total, 358, times column 1 total is 2000, and we will divide by number of n, which is 4000. And so that is now for this expected value. So let's just make sure. Expected value 258 times 2000 divided by 4000. The expected value is 179. Correct. Okay, observed value is the one that is in the table because we observe it. Observed frequency for row 1, column 3 is 174. That is also correct. Okay, so let's then look at here's your chi-squared stat and your chi-square critical. So that's the t-stat. Remember, t-stat bigger than critical value, we reject H0. So t-stat 0,331, and that is definitely smaller than your critical of 5992. So we will not reject the null hypothesis. Okay, so let's see, since 0.331 is smaller than 5.992, the null hypothesis of independence cannot be rejected. Okay, which is true. So we will not reject, cannot, correct. And then we just look quickly, they talk about p-value as well. Since the p-value of 0,847 is bigger than 0,05, the two variables are dependent. Okay, so that one is incorrect. So because that is bigger than that, the two variables are independent. It should have read. Okay, so because we cannot reject the null hypothesis, we assume that the null hypothesis are correct. So we assume that the two variables are independent. So since that p-value is bigger than that, again, the assumption will be that the two variables are independent and not dependent. Okay. So because we cannot reject the null hypothesis, we accept the null hypothesis. So if we accept the null hypothesis, we say that the two variables are independent. So you can't now with the p-value say, but sorry, they're not independent, they're dependent. It doesn't make sense. Okay, so this one should have been, if it was the other way around, then it is fine. But the p-value is bigger, so we definitely, the two values are independent, the two variables. Okay. So as always, another one. I think there's two more that we're going to go through, and each one is nearly the same process. So again, I will copy and we will just do it from the top. Also, that's for me, if I look at these, it's easier to identify H0, H1, and degrees of freedom. So those is nearly the easier ones if it is in the question set. Before we start really analyzing, looking at critical values, looking at test statistics, looking at the expected and observed. So let's again check in this one. Expected, we will work out something. Observed, we will just read it off the table. There's the degrees of freedom, critical value, and then again we need to make a choice. So nothing for H1 or H0, but we have the degrees of freedom. So let's see. Rows 1, 2, 3. So 3 minus 1. Columns 1, 2, 3. So also remember when we do this, so it's 2 times 2, which is 4. We don't include the total as one of the rows or as one of the columns. Remember, we're looking at all the classifications of bias age. So we don't include total. So there's 3 classifications. We look at car size. So there's 3 classifications. We don't look at total. So that's why 3 classifications, 3 minus 1, 3 classifications, 3 minus 1. So it's 2 times 2 is 4. Okay, so that is how we don't include the totals. Okay, so we've done degrees of freedom. Okay, observed value is the one that we read off the table. So let's see, observed frequency of bias under the age of 30. Okay, so it's that one. And a large car. So it should be 34. Okay. See the resemblance nearly in what we did in study unit 4 with probabilities. So that would have been our AND. The one where you are under age of 30 and you're buying a large car, that would have been 34. Okay, so just again, that's why with probability, we actually always test things for independence or mutual exclusivity. So here, again, that test of independence we are the whole time busy with. So just to see the link between the 2 study units. Okay, expected, let's work that out. Expected of bias above 45. Let's just get a different color in here. Bias above 45 and a large car. Okay, so large and above 45. The expected, oh, sorry. Now mixed up my 2 questions. So above 45 and medium. Okay. And then we see row total. So above row total times column total, the above column total, divided by n. And let's see what that is. So 120 times 99 divided by 300 gives us 39.6. Okay, which is correct. Okay, so then critical value. Dit was, okay, so there they gave us alpha. So let's look critical value. Let's rather write it here. Of degrees of freedom, we said is 4. Critical value of 0.05. And that is, so let's quickly go to the table as well. 4 and 0.05. 4, we're nearly covering everything at 0.05 nearly. Okay. 4, 0.05, 9.488. 9.488. Okay, which is correct. Okay, so then the last one, gonna check. So if T stat bigger than crit, we reject the null hypothesis. Let's quickly see. T stat, they say it was worked out as 18.35. That is bigger than 9.488. So we will reject the null hypothesis. And they say, suppose that the T stat is that H0 cannot be rejected. That is wrong because we will reject it. So option 5 is the wrong one. Okay, so you guys can see in this process nearly that we do the same questions or the same flow of how we work it out. And that just makes it easier when you guys need to do your assignment as well. Because again, there's certain things in a question that's easy to look for. And then there's certain things that you still need to work out. So sometimes we're lucky and we get, where was it that, oh, there was none of these today. Okay. Because sometimes you get it lucky that degrees of freedom is wrong. Or something like that, where some of the easy things are wrong and you don't need to then go further on and do lots of calculations. Okay, so let's look at this one. And first the trick, which one is correct? All the other questions was incorrect. Because suddenly two variables are dependent, independent. Okay, so that one is wrong. So again, just be careful, because all of the previous ones was looking for the incorrect one. Now you get to this one, you misread that, you pick one, you continue to the next question, and you think you've got it right because you picked the incorrect one. And I know I've made lots of those mistakes where you think it's the same, let's go for the incorrect one, but actually they want us to go for the correct one. Okay, so that should be independent, so it's wrong. Alternative should be independent, not, should be dependent, not independent. Wrong. Let's look at degrees of freedom. 2 minus 1. 1, 2, 3, 4. 4 minus 1. So it is 1 times 3, which is 3. So the degrees of freedom is not 8. But still, we're looking for the correct one. Okay, so still we've done that. We've done that. Okay, critical value. So let's look at critical value. So critical value of degrees of freedom 3 and at the 0,05. Okay, critical value 3, 0,05. Again, a 0,05. 3, so 7,815. Okay, so again, incorrect one. I just want to quickly check what was, if we use degrees of freedom of 8 with 0,05, just for interest sake. It was 8. To look at 8 and 0,05, 15.507. Okay, so if you went with that degrees of freedom, you would have gotten that answer as well. Okay, so that is where they got that 15,507, is if you worked with degrees of freedom of 8. Okay, so first 4 is all wrong, so this must be correct. But let's look. Expected frequency. So we're going to do this of a cell autumn. Okay, so that's autumn. So the total is 333 times the cell spar. That's spar. That's 560. And that we will need to divide by the total, which is 1,000. Okay, so let's quickly check. 333 times 560 divided by 1,000 is 186.48. Okay, which is the correct one. Okay, so again, a bit different to the previous questions. The catch here is definitely around how the question is set, because it doesn't matter if you guys read. So if you read that as incorrect, you probably could have gone for any one of those first 4, which is a bit scary. So this one, very important, nearly, just make sure that you read the question right. And then it was, again, most of this was tested. So you've got your hypothesis test that they did. They can test that as one question. They did the degrees of freedom. They looked at the critical value. So always the alpha will be part of this where we do the critical value. Here they did the expected value. So the only thing nearly not in this question is if we gotten the T-stat and you needed to make a decision on rejection or not. Okay, so that is our session today. So I think, and the guys that's later listening to the recording as well, for chi-square, it is nearly get in this method of using this table from your study guide. And you guys can, when the mock assignment is open, we will still go through that when we get access to that. But when your mock assignment is also open and you do the chi-square testing, follow this process, because we've seen now with this session today and the session we had on Thursday that it basically you can't get something else. So there will be a question around the hypothesis. There will be a one around the degrees of freedom. There will be something around the chi-square, the alpha that will link it to a critical value, because at this stage we have worked out the degrees of freedom. With the alpha, you can work out the critical value. Then there will be something around the expected or observed. Then the T-stat comes into play and you need to make nearly a decision by going to that chi-square table, look at the critical value, and then say, well, if my T-stat is bigger than my critical value, I reject the null hypothesis. Okay, so that is the steps. And that is the steps that you can follow. So if you now go again through study unit 10 and work some of those examples out in study unit 10, use this and check nearly just it's 5 or 6 steps. And even if I don't ask it, just tick it off that you see that there is the null hypothesis, there is the degrees of freedom, there is the critical value. Because that for this one, it is quite nice just to follow this recipe, and you will then get the answers that you're looking for. Okay, guys, have a great Sunday further. Hopefully in Cape Town the sun stays out, that we can warm up a bit. But yeah.